Hello my dear bright minds, welcome back to our physics class. Today we are going to discuss something regarding exciting topic, that is production of sound. Children, have you ever wondered when we clap our hands we could hear the sound, the ring of a bell and the tune of a guitar? So let us discuss together, let us find out together and do some activities based on that, and also we shall concentrate on the instruments that produces sound. So here we begin with sound and the production of sound. So, today's concept is all about the sound and their production. Children, what is sound? Sound is a form of energy and that travels in the form of a wave. I repeat, sound is a form of energy that travels in the form of a wave. Who produces sound? Any vibrating bodies produces sound. All vibrating bodies produces sound. Suppose the alarm of a clock, the barking of a dog, the ring of a bell or anything. We often communicate or talk to each other with the help of sound in our daily life. So, in order to propagate a sound, we require a medium. The medium can be solid, liquid or gases. But remember, sound can never travel through vacuum. So, this is all about your sound. So, let us recall back. Sound is a form of energy, travels in the form of wave. All vibrating bodies produces sound. The propagation of sound requires a material medium. Sound requires a material medium for that propagation. The medium can be solid, liquid or gases. But always remember, sound can never travel through vacuum. Got it, children? So now, the first activity to understand how the sound is produced is, let us consider a small example. So for this, let us consider a drum. What we do is, let us start beating the drum. When we beat the drum, observe that as far as the sound comes out from the drum, we observe when we touch the membrane of the drum, we feel as if the membrane of the drum is vibrating. And whenever the drum stops producing sound, again if we start touching the membrane of the drum, we feel no more vibrations of it. So, as long as the drum produces sound, the membrane starts vibrating. And when the sound stops, the vibration of the membrane also stops. So, from this we can conclude that as long as the body is vibrating, sound is produced. As long as the membrane of the drum is vibrating, sound is produced. That means vibrating body produces sound. Let us go with one more example. Children, let us go with one more activity. So, as a second example, let us consider a table. On a table, let us keep a long metal scale. A long metal scale is kept at the edge of a table. What we do is, by holding the other end of the metal scale with one hand, start vibrating the free end. So, one end is held with the hand, pressed with the hand, and the free end we have to press down and should be released so that the scale moves, the free end of the scale moves up and down and up and down so that the scale starts vibrating. So let me show you the same. So whenever the scale starts vibrating, it goes up and down and up and down. So like this, the scale will move. This is how the scale starts vibrating. The movement of the scale is observed. Some more I'll help you. So, as long as we observe that the scale is oscillating or vibrating, moving here and there, up and down, the sound is heard. But after some time, when the scale starts vibrating, no more sound is heard. So, this example also gives very clear that as long as the body starts vibrating, sound is produced. No more vibrations means no more sound. So, this example also very clearly tells us that vibrating bodies produces sound. Okay, children? Children, sound can never travel through vacuum. Okay? Well, for that, I'll consider one more example. A small general example I would like to tell you, children. Just hold a stretched rubber band. Take a rubber band and stretched rubber band I require. Keep one edge of the rubber band in your mouth and simply stretch the other end of the rubber band with another hand. So, holding the one end with your mouth and stretching it with the other hand, what we do is just tap it or apply some force at the middle of the rubber band. What happens? The rubber band starts vibrating. So, when some force is given, applied at the middle of the rubber band, definitely and released, the rubber band starts vibrating up and down and up and down. So, as long as this rubber band vibrates, we could able to hear hear some sound. And after some time, when this rubber band no more vibrates, no more sound is heard. So this is also a general example where we can get to a conclusion that vibrating bodies produces sound. So whether it is a drum, whether it is a long metal scale, or whether it is a stretched rubber band or any other example of your daily life, we can come to a conclusion that all vibrating bodies produces sound. Okay, children? But let us try to understand with one more demonstration or one more experiment that sound really requires a medium for their propagation, or whether the sound can also propagate in vacuum. For this, let us consider one more experiment or demonstration. So for this, let us consider an electric bell. So this is the case of an electric bell, children. To demonstrate sound requires a medium for propagation. So what are the, let us try to understand the apparatus properly. This is very clear that this is an electric bell. This is an electric bell, children. Okay, so these are the two stands to which rubber bands, this orange color are the two rubber bands, they are clamped to the electric bell. And this pink color, it indicates the glass jar. What is that? Bell jar or glass bell jar. So the pink color, this is the complete electric bell is enclosed in a glass jar or glass bell jar. This inside part is an electric bell, up to which a rubber cork is being connected and through which some electrodes have been passing on, and there is an outlet for the air to come. So whenever the circuit is closed, and one more thing, children, here is a vacuum chamber, vacuum pump we can say. Okay, the bottom we have provided with a vacuum pump. So let us try to understand the working of this electric bell jar. Whenever the circuit is closed, what do you mean by circuit is closed, children? Whenever the switch is on. Whenever the switch is on, what happens? The electric bell starts working on. So how does the electric bell starts working on? This, whatever is there, alarm bell. So this starts vibrating and it continuously beats that electric bell. So whenever the switch is on, the current passes through the electric bell and it starts vibrating. As long as it is vibrating, we are able to hear some sound. And what is all inside? Inside that glass bell jar is provided with some air. Let us demonstrate one more activity to understand that all vibrating bodies produces sound. So for this, let us consider a small apparatus. First of all, we require a retort stand. Retort stand is something like this, generally used in laboratories. This retort stand is provided with a Yes. This is how a retort stand looks like. To this stand, what we do is, let us suspend a tennis ball. Let us suspend a tennis ball with the help of a small thread. So what we are suspending, children? This is your tennis ball. So what we take is, let us consider a tuning fork. What is a tuning fork, children? A tuning fork is a small apparatus generally we use in laboratories. Somehow it looks like this. So this is a tuning fork. This is called the stem of a tuning fork and these two are called as the prongs of a tuning fork. So whenever this tuning fork is hit with a Whenever this tuning fork is hit with the help of a rubber hammer, this is a rubber hammer. So this is only material, the soft material made up of rubber. So this is a material generally made up of steel or iron, steel only. Okay. So this prongs of the tuning fork is struck with the help of a rubber hammer. So whenever it is beaten with a rubber hammer, what happens means the prongs of the tuning fork starts vibrating. The prongs of a tuning fork start vibrate. So this will come in this direction, this will again go in this direction. Here also it comes forward and comes backward. So the prongs of the tuning fork start vibrating like this, like this, like this, like this. As long as the prongs of the tuning fork starts vibrating, sound is produced. How to understand that? So take this tuning fork near to that ball. So even though we are not able to see whether it is, sound is only heard, we can't able to see whether this is vibrating or not. But you could able to hear the sound. So whenever after striking with the rubber hammer, this tuning fork is is carried near to the tennis ball, we observe that the tennis ball starts oscillating. Why does the oscillating? Because the energy from the tuning fork in the form of sound is transmitted from the tuning fork to the rubber ball, a tennis ball, and hence the tennis ball starts oscillating. So this is an example. So this is a tuning fork, a tennis ball, rubber. This should be clamped to the retort stand. Whenever it is struck with a rubber hammer, the tuning fork, the prongs of the tuning fork starts vibrating and the sound is being produced. The same is if it is carried to the near to the tennis ball also starts oscillating. So here is the best example to understand that all vibrating bodies produces sound. Okay, and that vibration can be seen with the help of a oscillating tennis ball. Okay, children. So from this, we conclude the concept regarding the worksheet number 4. So look at the worksheet number 4, level 1 questions, my dear children. Not to travel through vacuum. Okay, it requires some medium for its propagation. The medium can be solid, liquid or gas. Okay, children, one thing you need to remember, children, sound travels faster in solids as compared to liquids and gases. Sound travels faster in solids, about 10 times faster when compared to the air. Okay, so later we shall discuss in detail regarding this. Moving to the second question, vibrating bodies produces. All vibrating bodies produces sound. So here the next correct option is all vibrating bodies produces sound. Now the third question, which of the following statements is true? Sound and light both require medium for propagation? No. Light is an electromagnetic wave which can also travel through vacuum, but sound cannot travel through vacuum. So of course sound requires the medium for its propagation, but it's not the case with respect to the light. Sound can travel through vacuum? No, wrong statement. Sound needs medium, yes, but light does not need any medium for its propagation. Obviously, it's true. Sound need a medium for their propagation, but light does not need a medium for its propagation. Sound and light both cannot travel in a medium? Both can travel in medium. Why not? So, what is the correct option, my children? Third option is correct. That sound needs a medium for its propagation, whereas light do not require any medium for their propagation. It can even travel through vacuum. The next question, fourth one, the sound travels fastest in. Just now I told you, sound always travels fastest in solids and low in gases. So which one is the correct option? Sound travels fastest in solids. Now, moving to the next one, the instrument used in the laboratory to produce sound of a fixed frequency, children. So, what is the correct answer, children? Tuning fork is the instrument used in laboratories to produce sound of a fixed frequency.